Now, in this video, we will take up one more problem on projections of laminas, how to analyze this problem in 3 dimensions, and also how to solve this by using the manual sketch. A square plate of 30 mm sides rests on HP such that one of its diagonals is inclined at 30 degrees to HP and 45 degrees to VP. Draw its projections. So he says rests on HP. So since he says it is rest on HP, so obviously you need to start the problem from the top view. Because it is on HP, the views which you can get on HP is only the top view. So how to place the square plate? Whether it should be resting on edge or a corner. If you rest on edge, then that edge is perpendicular to VP. If you are considering that here, if you want to keep this on an edge becomes perpendicular to VP, then the diagonal will become inclined to VP. Since the diagonal becomes inclined to VP, so if you look from the front view, then the diagonal will going to have an apparent length. But from the projections of lines, on the true inclination, you will going to get the true length only. But the problem what it says, the diagonal is inclined at 30 degrees to HP and 45 degrees to VP. So since he has given the true inclination, but when it is kept on the edge, the diagonal will go to become the apparent length. So it is not possible to find the true inclination or the true length and then to use it. So if you want to do that, again we need to rotate in the top view, make that diagonal parallel. Instead of doing that, what we do, we keep the square plate with one of its diagonal parallel to VP itself. If I keep the diagonal, one of the diagonal parallel to VP, you can see here, the diagonal AC is parallel to VP. If you keep it like that, then you will going to get the true length of the diagonal in the vertical plane, that is in the front view. So therefore, we need to keep the square plate in corner position instead of keeping it on edge. So now how to proceed with the problem? So first we need to create a square of 30 mm side such that one of the diagonal is parallel to VP. So this is possible only when you keep the square plate in the corner position. Once you keep the square plate in the corner position, you can see the diagonal AC is parallel to VP and the diagonal BD is perpendicular to VP. So when you look from the front view, you will get ABC is near to the observer, so A dash, B dash, C dash is visible, and D dash is away from the observer, therefore D dash is in bracket. So what is the position of the square plate with respect to both HP and VP? The square plate is parallel to HP. Since the square plate is parallel to HP, that means all the sides are on HP. So obviously those sides are parallel to HP. Therefore, you will going to get the true length in HP. So you can see AB is equal to BC is equal to CD is equal to DA, which is equal to 30 mm. So it will going to get the true shape. Now in the front view you can see A dash B dash is AB is inclined to VP, so A dash B dash is in apparent length. Similarly, BC, CD and DA all are in apparent length. But if you consider the diagonal AC, when you look from the top view, both A and C are in front of VP by same distance. Now the diagonal AC is parallel to VP. Therefore, you are getting the true length in the vertical plane. That is A dash C dash is the diagonal which is true length in the vertical plane, and BD is the diagonal wherein parallel to HP. Since it is parallel to HP, so you are getting the true length in the diagonal BD. But since it is perpendicular to VP, you are getting a point in the vertical plane. Therefore, B dash is visible and D dash becomes invisible because D is away from the observer. So how to proceed this? Now, the position of the square plate is parallel to HP and perpendicular to VP. Therefore, in vertical plane, and that is in the front view, you will be able to see it is a line. Now, how to start with this problem in the sketchbook? First, you take any point First we are going to draw the XY line and you mark VP and HP. So consider any point B and you draw a horizontal line by using the protractor with B as center. Take an angle of 45 degree with respect to the left side and also with respect to the right side, and with respect to the horizontal you draw an inclined line. Then by using the compass with B as center, take a radius of 30, cut an arc on the left side of the line which is drawn at 45 degree, and similarly on the right side of the line which is drawn between these two. Then you mark these points as A and C. By using the same radius which is 30, with A as center, draw an arc here. With C as center, cut the previously drawn arc to get the point D. Then join A to B with a dark line, B to C, C to D and D to A with a dark line. Then join A to C and B to D with a thin line. So these two, AC and BD, are the diagonals. Then draw a vertical projector from A, B and D and C to the XY line. And as you look from the front view, A dash is near to the observer, so it is visible. B dash is near to the observer, it is visible. And C dash is near to the observer, it is visible. And D dash is away from the observer, so it is in bracket. Then join A dash to C dash with a dark line. So once you do that, so you can see A dash is a corner and C dash is also a corner. Now, then we need to so it is just so that the diagonal inclined at 30 degrees to HP. So which is the diagonal which is inclined at 30 degrees to HP? AC is the diagonal which is inclined at 30 degrees to HP. How do I do that? So keep the C on XY line and you rotate the square plate such that the diagonal AC becomes 30 degrees to HP. So that inclination you can see in the vertical plane when you look from the front view. So what happens to the image as we rotate this object in 3 dimensions? What happens to the image? The image in the front view is being rotated by an angle of 30 degrees. Then when you look from the front view, you can see that the surface is perpendicular to VP. So therefore, you are getting a line here. So whatever you have, that diagonal which is 0 degree with respect to HP has become inclined at 30 degrees to HP, and still that surface is perpendicular to VP. Therefore, you are getting a line in the front view. So you are rewriting the same sketch by an angle of 30 degree with respect to HP. Then when you look from the top view, A is being projected onto the horizontal plane, B is also being projected into horizontal plane, and C is already on the horizontal plane, and D is projected onto horizontal plane. And when you join this AB, BC, CD and DA with a dot line, and of course you join between AC and BD. So then what happens? And then if you see that AB, A dash, B dash and B dash, C dash, C dash, D dash and D dash, A dash all are inclined to HP. Therefore, you are getting the apparent length in the top view. And since AC is the diagonal which is A dash, C dash is the diagonal which is inclined to HP, so still that is in apparent length. But what happens to the diagonal BD? B dash, D dash is parallel to HP. Therefore, BD still is in true length. So this BD will be in true length, whereas this AC is in apparent length, because AC is the diagonal which is inclined to HP, so you are getting the apparent length in HP. BD is the diagonal which is parallel to HP, therefore whatever the length you have here, the same length is continued here also. Then how to draw this in a sketchbook. So to do that, so you take any convenient distance from C dash to this point and consider any point on the XY line and you mark that point as C dash. By using the protractor with reference to the XY line, you measure an angle of 30 degrees and then draw an inclined line. By using the compass with C dash as center, take the radius of C dash A dash and transfer it from C dash to on this 30 degree line, and you mark this point as A dash and then join A dash C dash with a dotted line. Similarly, you measure the distance from C dash to B dash and transfer from C dash on this 30-degree line, and you mark that point as B dash and D dash in bracket. So this is how you will be able to transfer the position of the first position front view by an angle of 30 degrees. Then you draw a vertical projector from A dash and C dash to the top view, and draw a horizontal projector from A and C. Both these two lines will going to intersect at this point and also at this point, and you mark these 2 points as A and C. Similarly, draw a vertical projector from B dash and D dash, and draw a horizontal projector from B and D. These 2 lines will going to intersect at these 2 points, and you mark this point as B and you mark this point as D. So then join A to B, B to C, C to D and D to A with a dark line. Now as we see this, what happens? AC is the diagonal which is inclined to HP, so you are getting the apparent length here, and BD is B dash, D dash is parallel to HP, therefore BD here will be in true length. Now then what I need to do? See, the diagonal which is inclined at 30 degrees to HP is become inclined at 45 degrees to VP. So the diagonal which is inclined to HP has become inclined to 45 degrees to VP. So that is the meaning. So that means the diagonal what you have here, this is the diagonal which is being inclined to VP at 45 degrees. But the inclination given is the true inclination. Therefore, I cannot rewrite this same sketch by rotating at an angle of 45 degrees to VP, because the inclination given is the true inclination. Since the inclination given is the true inclination, but whatever you have the diagonal here is on apparent length, so I cannot rotate on to this 45 degree line directly. So since this length is in apparent length, I need to find out the apparent inclination, and then only we need to rotate it. So how to do that? So when you take 45 degree with respect to VP, you draw a 45 degree line with respect to VP. Since it is the true inclination line, so we need to take the true length of that 45 degree. So which is that A dash C dash is the line which is parallel to HP. So you are getting the true length in HP. So you take the diagonal AC with considering any point, mark that point as A. So with that as center, cut an arc on this 45 degree line, and you will go to get the locus. Then you take the AC, which is the second position top view, which is in apparent length, with a same A as center, cut an arc on the locus line. So you got C. Now we have this line. So you have C here and you have here A. Then you rotate this A, B, C, D, which is in space, onto this. So you are going to get A to B, B to C, C to D and D to A with a dark line. So this is the gray position, whatever you have. This is the line which is in space. Now when you look from the top view, A is being projected onto the horizontal plane, B is also projected onto the horizontal plane, D is also projected onto the horizontal plane. Of course, C is already on HP. So therefore, A to B, B to C, C to D and D to A. This is the image what you will going to get for the square plate which is in space now. And when you look from the front view, this A is being projected to vertical plane, B is being projected to vertical plane, D is also being projected to vertical plane, and C is also being projected to the vertical plane. So then join A dash to B dash, B dash to C dash, C dash to D dash and D dash to A dash. So this will going to be your final position when this object or the square plate is in space. And this is how you will be able to analyze this in 3 dimensions. So this is the actual position what we need in the final position of our drawing. Then this is about in 3-dimensional space. How do I convert that? How do I draw that when you are going into the 3rd position, top view and front view? So how can I do that? So first you consider any point and draw a horizontal line. With reference to that horizontal line, with A as center, you mark that point as A. With A as center, with respect to the horizontal, you measure an angle of 45 degrees. This is the line which we are talking about, 45 degree line. Then you take, since it is the true inclination line of the diagonal, take the true length of the diagonal, which is here, AC. With A as center, cut an arc on that 45-degree line. You get the distance. Then draw the locus line with reference to, draw a locus line. That means from this point, you draw a horizontal line, which is the locus line. Similarly, as we know, this is as the diagonal AC is already inclined to HB, therefore you are getting the apparent length. So with A as center, by using the compass with A as center, take the radius of AC in the second position, top view, that is this distance. With the same A as center, cut an arc on the locus line and you mark that point as C. Then join A to C, which is a thin line, because that is the diagonal what we need to find out. So you mark that angle as beta. Then transfer this entire sketch on this apparent inclination line. How to do that? By using the compass, you measure the distance from A to this point and transfer from the same A onto this. Since this vertical line is perpendicular to the AC, so through this point with respect to AC, by using the protractor, you measure an angle of 90 degrees and then draw this line. This is the line which is perpendicular to AC. Then you measure the distance from this point to B and also from this point to D. Both will have equal distances, and transfer this from this point toward this side, and you call this point as B, and again from the same point you transfer it onto this side by using the compass and you mark that point as D. Then join A to B, B to C, C to D and D to A with a dark line. Then you need to write the front view. How to write the front view? Draw a horizontal projector from the second position front view, A dash, and draw a vertical projector from the third position top view, A. Both these two lines will going to intersect at this point. You mark that point as A dash. Then similarly, draw a horizontal projector from B dash and D dash and draw a vertical projector from both B and D to the front view. These two lines will going to intersect at this point and this point. You mark those 2 points as B dash and D dash and draw a horizontal line from C dash and draw a vertical projector from C, both these two lines to the XY line, since because C dash is on XY line in the second position front view. So mark this point as C dash, then join A dash, B dash, B dash, C dash, C dash, D dash and D dash, A dash with a dark line. And this is how you will be able to analyze the drawing in 3 dimensions and also to solve that by using the sketchbook. How do I know that my problem is right? Even in the final position, you can see that C dash is on XY line and the diagonal which is inclined at 30 degrees to HB, the same diagonal is inclined at 45 degrees to VP, means what? You need to find out the beta inclination. So we have found out that beta, and since it is a square plate of 30 mm side, with one of the diagonal becomes parallel to VP, which is AC, which will going to be the true length. So this is how you will be able to analyze and solve the problem by using the sketchbook. Thank you.